Good morning and once again welcome to my YouTube channel, Pearson Excel International Maths by Mr. Kamoto. And of course, today we want to get to the final stretch of quadratic equations, whereby we learn how to solve quadratic inequalities. You realize that squares and square roots involving inequalities, of course, need a lot of care. Because the word inequalities means it's a region. We are going to get a region. We are not going to have a specific answer. We are going to have less than, greater than, or something like that. But anyway, if you look at example 15, let's talk about example 15. We are going to solve, it's asking us to solve x squared minus 4 is less than 0. The one very fundamental thing and rule you are supposed to undertake here is that assume you are not even seeing the inequality and talk about y is equals to x squared minus 4. And when y is equals to x squared minus 4, now you can extend this one to x squared minus 4 is equals to 0, so that you can get the critical values and you can solve it as a quadratic equation. 0 because when y is 0, then x squared minus 4 is going to be 0, and that is where this graph possibly intersect the x-axis, because the x-axis is y is equals to 0. And we call those the critical values or the solutions of this particular quadratic inequality. So it goes without saying that x squared is equals to 4 and x squared is equals to plus or minus 2. And these are now what we call the critical values. We can sometimes call them solutions of x squared minus 4 is equals to 0. If we were solving that inequality, then this would have been the answers, plus or minus 2. But because we are solving an inequality, we sketch the graph now. This is minus 2 and this is plus 2. And we examine the nature of A, which is A is greater than 1, and therefore we expect a U shape. When A is less than 1, we expect an N shape. This one will be understood later. And this is A is equals to 1, and therefore a U shape. It's also important to know, where does the graph cut the y-axis? It cuts the y-axis when when x is equals to 0. So this is simply minus 4, because 0 minus 4. If you substitute here, 0 minus 4, that is, if you substitute over here, y is equals to x squared, which is 0 minus 4. So y becomes minus 4. But the moment we are now there, we must examine our original inequality. What was it saying? Less than 0. So anything that is less than 0, it is the one which we expect, because x squared minus 4 is less than 0. So we can easily shade the region that is above 0, and we call this region unwanted. This is unwanted region. And this is now the region that is making sense as far as this inequality is concerned. And for this to happen, you can already see that it's a continuous region, and therefore we are going to form a single compound inequality. X is greater than minus 2, and the same x is less than positive 2. Greater than minus 2 and less than positive 2. If x dwells within that region, then this function makes a lot of sense, and this therefore becomes the solution to that particular question. If we may discuss example 16 in the same video, we are supposed to solve x squared minus x minus 2 is less than or equals to 0, and show the solutions in the number line. show the solutions in the number line. As I told you, we need first of all to ignore the inequality and solve x squared minus x minus 2 is equals to 0. So that we can employ all the methods, probably we can go to BAC, it's straightforward. B is minus 1, you can see AC is minus 2 as you can see. And two numbers you multiply, they give you minus 2, that is minus 2 times 1, and this is minus 2 plus 1. So we break the middle term and have x squared minus 2x plus x minus 2 is equals to 0. So we have the common factors in the first two terms, that is x minus 2 plus 1, x minus 2, and this being equals to 0, x minus 2, x plus 1 is 0. We are now looking for the critical values, or rather where the graph cuts the x-axis. At this particular point, you would clearly see that x is equals to 2 or x is equals to negative 1. And again, as we sketch this graph, it's important to realize again, the graph is a U-shape simply because you can see A is greater than 1. So, but the critical values is negative 1 and positive 2 as indicated here. Again, when x is 0, what is y? When x is 0, y is simply minus 2 because 0 minus 0 minus 2 is actually minus 2. And at that point, we revisit our original inequality, which stated that x squared minus x minus 2 is less than or equals to 0. So again, the region that is below 0, because this is when y is equals to 0. This is the line known as y is equals to 0. And we shade the unwanted region. We don't want that region. So again, we are dwelling our solutions within this continuous region. And if the region is continuous, then we can form a compound inequality. X is greater than or equals to negative 1, and x is less than or equals to 2. The reason why we brought less than or equals to is because our original inequality had less than or equals to 0. So we have to obey that. That means the limits are included. These limits in the first example, they were not included, and that is the answer. In the number line, then we talk about minus 1 and positive 2, and you can see that is shaded and that is shaded, indicating that the limits are inclusive as well. And that is just like it. Allow me to probably explain example 17 in the same example 17, and we are told that solve x squared minus 5x plus 6 is greater than or equals to 0. Now we are dealing with greater than or equals to 0, but as I told you, we are going to sketch our graph here. So let's work here. X squared minus 5x plus 6, let it first of all be equals to 0 so that we can easily get the critical values. If we go BAC method, you can see which two numbers we add, they give us a minus 5, and the same number we add, they give us a positive 6. Obviously this is minus 2 and minus 3. So x squared minus 2x minus 3x plus 6 is going to be equals to 0. So x minus 2 minus 3, x minus 2, this is 0. I'm working out fast because I don't expect anybody in this level not to understand exactly what is happening here. So we form two brackets, x minus 3, x minus 2 is 0. And if this is true, x is equals to 3 or x is equals to 2. And those are the critical values. And when we are solving, when we are drawing now, sketching our graph, we must indicate those critical values. We would have probably this is 2 and this is 3. I don't know the nature of the graph, but of course a is greater than 1. So we are going to have a U shape. The graph is looking like this. It's going to have a U shape. It's going to have a U shape. And of course, when x is 0, this is 6. You can see that. Fine. The graph, or rather the question, talked about greater than or equals to 0. So this is the unwanted region, because now we want when y is greater than or equals to 0. But of course, in that particular setup, you can see we have two regions in our graph, or rather, the acceptable regions is not continuous. We have that region and that region. And if it is not continuous, then we cannot have a single compound inequality. Of course, for this to make sense, x has to be this particular value or below. And what is this value? This is 2 and this is 3. X has to be 2 or less. And for this to make sense, x has to be equals to 3 or more than 3. So that is exactly how we will do. And because you can see the wanted regions are separate, it is completely impossible to form a compound inequality, one compound inequality that represents these two regions. So we are going to have x is less than or equals to 2, because it makes sense for this particular region, because the more x becomes smaller, the more y becomes bigger, and we are looking for something for y that is going to be greater than 0, which is acceptable in that region. For the other one, x has to be greater than or equals to a 3 for the whole of that statement to make sense. You can see as x increases, y also increases. As x increases, y also increases. And because we want y to be greater than 0, then those two inequalities make a lot of sense. It is not possible to come up with one inequality whereby we say x is less than or equals to 2 and the same x is greater than 3. I don't see an x which is less than 2 and the same x is greater than 3. It doesn't make sense. So that one is a no-no, and it means that when we are talking about two separate regions, we must give two separate inequalities as your answers. Fine, that is as far as quadratic inequalities are concerned. Please follow and make sure you subscribe and share widely so that we work together. All right.